Okay, so let's go ahead and get started. Thank you all again for coming back for our second day of visualizing the COVID pandemic. Um, so today the plan is to, we spent a lot of time yesterday talking about Observable and the features and interface and syntax of it. So I kind of want to start today with a discussion of the various COVID data sets that are available for us to use in our reporting and chart building. There's a few that I think I mentioned yesterday that I wanted to just kind of surface for everyone and talk a little bit more about. I would also, this is a time that I have set aside that I want to hear from you all about people who are out in the field actually reporting on the COVID pandemic and what data sets they're using and even some challenges or just a little bit of time for a discussion about how the pandemic is being measured in all of our different coverage areas and how we're able to use the information that's available to us to do our jobs. And then so once we have like a kind of sense of some of these data sets, the next thing I want to move on to is talking about Vega, which is the data visualization library and framework that sort of works really, really well in Observable as well as other places. We'll talk a little bit about how the sort of ideas behind Vega, and then sort of like immediately turn around and put those into practice in building some charts. We're going to make a few simple charts at first, and then actually create an observable notebook that will allow us to sort of generate charts without having to write code. And then if we have time, and I'm not sure that we will have time for this, we're going to try and do a cartographic chart. That's a county level COVID case map. I'm not totally sure we'll get to that. If we don't, you know, all the resources and the notebooks that that are sort of connected to this workshop, we're going to be sharing those with everybody who is a participant, as well as the public. So, you know, whatever we're not able to cover in the next hour and a half, we will be sure to share with you as a follow-up. So I hope everyone's excited to get going today. So let's go ahead and get started. So yeah, to start off, let's talk about some COVID data sets that are out there, because one of the things that became sort of, I think, really immediately obvious to a lot of people is that we couldn't really rely on any sort of central government authority, in at least in the United States, to sort of show all the different facets of the pandemic in different localities. And so, you know, in that sort of vacuum of information, you had a lot of different people step in, journalists in particular, people adjacent to journalism, to try and fill in that information vacuum. And so, you know, that includes like you know, national news organizations like the New York Times, which has you know, produced a lot of interesting interactives that are sort of updated daily to show how you know, where coronavirus is, you know, where COVID cases are happening in you know, counties across the country, as well as hotspots. And all the data that is behind these interactives, the New York Times has made available via one of their GitHub repositories. So if you don't know what GitHub is, it's basically an online platform for sharing code and data sets. Really, it's mostly for open source code projects, but you can store data files in GitHub as well. And so, you know, it's used by lots of different news organizations to share resources including in this case all of the data files that the New York Times has collected. You can just go to this repository on GitHub and download their data or sort of reference the location of their data in your projects. I'm actually just going to drop this in the chat real quick so other people can kind of peruse it and bookmark it as needed. Where's my chat window? Sorry, just one second. The chat window is here. Okay, yeah. So they have like several different data sets, including a sort of historical data set, which is like the number of cases and deaths that have been reported like cumulatively up to the each date. That's so that for each one of these data sets, or they have like a state level, a US level, and a county level, right? So there's the historical data, which is you know, sort of you have an observation for each date, versus the live data, which is the sort of current count for each state or county or the country. And we can sort of see these data files if we sort of drill into the yeah. So here's the one for the U.S. states, for example. And you know, GitHub will actually kind of, this is actually a CSV file, but GitHub is just sort of rendering the file for us in a nice sort of readable format. But there's a raw version, a raw URL that gives us like just the plain text version of the CSV file, which we'll show you how to like sort of use that in making a chart. You know, one of the things that is sort of explained in here, and this is something I'd like to maybe take some time to talk about, is how you know, each state is having you know, has sort of different practices in terms of how they are counting confirmed cases and deaths. And so, you know, I think the way the New York Times builds this data set, as far as I know, is they have lots of people, journalists, calling these state and local officials every single day to get updated numbers, or they sort of develop those relationships to sort of get the data as needed. And so you'll see like the files in here are often updated. Yeah, it looks like they just dropped the newest ones like 22 minutes ago. So, and this is like a big, you know, collaborative effort. I know there's some students that I work with at the Missouri School of Journalism who have been assisting in this effort. And so, you know, this is kind of the nature of the problem that we're facing, as it requires a lot of these kinds of cross news organization collaborations. Speaking of that, another effort that's sort of similar to the New York Times is something called the COVID Tracking Project. This is an initiative that began with some folks at the Atlantic. Alex Madrigal, I believe, was the main person spearheading this. And now you've got Aaron Kassane, formerly of the Night Open News organization, as the managing editor. But so they have their own data files that are sort of being compiled by an army of volunteers across the country who are, again, just sort of collecting the information in their own localities. And one thing I've noticed about this data set is that it gets, there are like more, there's sort of more variables for each state. We can actually kind of look at that real quick. We'll look at the state level real quick, data by state. So this includes like the number of tests and the negative ones, and they also have sort of calculated fields for the cumulative versus the current number and the sort of number of changes. You can get this data in a JSON format or a CSV format. You can just download the spreadsheet from this URL as well. So I'm actually going to drop this in the chat as well. Definitely a really great resource that I see a lot of people using. So if you haven't seen that already, definitely check it out. Another really good sort of independent organization is the USA Facts, which has its own sort of section for, somebody says, I'm not seeing anything, he's dropping. I'm sorry, it looks like it's going out to the panelists, not to all participants. Sorry about that. Thank you for bringing that to my attention. Let me just fix that. All panelists interviews. Okay, so there's the one for the New York Times. And here's the one for the COVID tracking project. And here is the one for USA Facts. So usafacts.org has a lot of data sets available, just sort of covering lots of different lots of different topics, but they've created their own sort of special section for coronavirus. And so you can use their data as well, and it's free and open to the public. And they, as far as I know, are a pretty reliable organization. I see lots of people using their data in my Twitter timeline and in lots of other news stories. So another sort of resource for anyone who is looking for information. It goes down to the local level as well. I don't know about the county level. The only one I've seen for that is the New York Times so far, but I could be wrong about that. Just a couple more that I want to mention is a resource called data.world, which is being used by the Associated Press to release data sets that they compile as part of their big projects that they make available to member organizations. So if you are if you work in a news organization that is an Associated Press subscriber, it's possible that you have access to this information. I think it's an add-on service. I don't know much about how it works for news organizations, but I will say that I have some subscriptions to the Associated Press data.world account that I've been using for the class that I teach at Missouri. This is something new that I've been trying. They put out a lot of really great stuff that is really easy to like pick up and use, because this platform data.world is kind of it's a sort of third-party organization that is trying to be like a sort of data science and data sharing platform. But the Associated Press has sort of bought into that, and they have their own sort of organization account, and then they'll release data sets on our sort of, I think it's every couple of weeks, depending on, for coronavirus, I've seen them pushing out stuff like every single week, even sometimes multiple days in a row. I had some students diving into some of the data sets they were compiling around the U.S. Unemployment figures, it's they were able to like produce some really cool analysis and charts using that data. What's nice is that they, in any one of these examples of sources I brought up, is like you've got some trustworthy folks who are kind of doing the grunt work of like getting and compiling the data and sort of preparing it for your use. Yeah, if you are interested in you aren't working in a news organization that's an AP subscriber, you might talk to the folks in the know at your organization about getting access to the data.world data that's available. So like just one final resource I'll throw out there is this new initiative called Big Local News, which was started by Cheryl Phillips, who is a colleague of mine from my previous role at the California Civic Data Coalition. Cheryl teaches computational journalism at the at Stanford, and one of the things that she just well, the project she's been working on for I think a year, 2 years now, is this new sort of similar to data.world, like a platform for data sharing. But you know, her goal is to really cater to news organizations. She also is working with people at the Stanford Stanford sort of library science department. You know, Stanford has like an archive that if you they think the goal of Big Local News is that any data set that you put into it will be archived through Stanford's like archive. So it's like you know, like a permanent thing. Like the old idea for this project came from Cheryl's experience as a journalist, and just you know, someone a journalist who relied on lots of data that she collected, and you know, and just always like wishing that she had a place where she could you know, sort of archive her data sets that she had collected for like really important stories that she'd done, and like share it with other you know, colleagues, so that's was sort of the idea for this thing called Big Local News. It's sort of a new, they just launched in spring. I think they kind of announced things at the NICAR conference in New Orleans this March. If you have a Google account, I think you can sign up for it. And so they have some data sets that that are related that are sort of being submitted by folks all across the country related to COVID and lots of other things. So you might check that out as well. So now I kind of want to hear from you all about you know, successes and challenges you've had in covering COVID and using data to do that. Has anybody have any other experience that they want to share about data sets that they've been able to use or had trouble using? Now's the time. I guess you can just sort of drop your drop a message in the chat, and I could possibly also just maybe even try to like turn over the mic to whoever wants to talk. I'm happy to like have other people speak besides me the whole time. So anybody have anything they want to share about data sets related to the COVID pandemic? I'm interested in data sets about meat packing plants. Oh, here it all comes in once. Okay. So that's an interesting question. So I haven't really followed that issue that much, although I, you know, as a carnivore, I'm pretty interested in that as well. I don't know. I haven't seen anything, any sort of like sort of broad effort to like collect data about meatpacking plants and outbreaks. Does anybody else know anything about that? I mean, we've had a few stories in our local NPR affiliate about just sort of plants that are nearby, but it's an interesting point to raise. Okay, so Brandon Lewis says, our county's been good at providing the data daily. We've been tracking it on spreadsheets, but need help displaying it in a consumer-friendly format. Cool. So one thing I'll say is that, you know, we'll show you how in Observable you can upload those spreadsheets and then just sort of like rerun your notebooks whenever you want to. So we'll talk more about that. So Josh says, I use the COVID tracking project, worked very well, and was able to get to use CSV charts to crunch numbers. Yeah, I think the COVID tracking project's really, really awesome. And I mean, I think it's just really cool that somebody like took the, had the, initiative, took the initiative to like put this whole giant effort together and get it going, because, if not them, who, right? Somebody else. Nobody has accurate, timely data at local county level for coronavirus cases, at least for my locality. Yeah, I mean, I think that's been a problem that lots of people have been raising. Exactly how county and state officials are counting a positive case, whether they're, I mean, I didn't think I was hearing about this. This filters all the way up to the international level, right? Like, I think there was a news story recently about how the way that China was counting, it was reporting its cases, was that it was reporting people who like tested positive, but we're only reporting people who tested positive and were also symptomatic, not necessarily people who tested positive and were asymptomatic. I think they revised the way they were reporting that as well, but that was something that was filtering all the way up to the World Health Organization. And it's also worth saying that, like, we've seen some reports about the accuracy of the tests, like false positives and false negatives, which just kind of really drives home the sort of uncertainty of this. And it's a challenge as journalists, right? Like, people are really clamoring for information, but we have to find ways of, like, giving them the best version of things, while acknowledging that, this is science, and science is a process, and the outcomes and the claims will shift based on new information, finding ways of doing that without getting people, it's sort of undermining the a belief in an empirical reality, right? So somebody else, I'm just gonna go through some of the other chats here. Johns Hopkins has county level data updated more often than NYT. That's great to know. I didn't know that. Thank you for sharing that. And it's worth saying that Johns Hopkins has been, like, amazing at the data sets that they've been releasing. So thank you for sharing that, Justin. Meatpacking plant outbreaks have impacted immigrant workers. So would this be in racial data? That's a good question. I don't know the answer to that. The racial tracker, that data tracker that the COVID tracking project just released, I haven't looked into that very much. It's probably worth, it would be worth digging into that yourself to find out. Which of these open data sources have you found is updated most frequently? Just full disclosure, I don't work in a news organization or as a journalist, so I'm not looking at this stuff every single day. As somebody just mentioned, Johns Hopkins is, they say it's updated more frequently, which is good to know. But the New York Times, that's the one I've kept the most track of, and they have, they're putting up new files every single day. So they're a pretty good place to go to, as well as COVID tracking. Bug your state health department for things like workplace and long-term facility outbreaks. That is a really, 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 really good point, because we've experienced that in Missouri as well, where they're not releasing the counts of cases at these long-term care facilities, which is really disappointing, right? Because people who have family members and friends in these facilities, they really want to know about the safety of those places, and it's a shame that that stuff's not, they're not being more, that state health departments aren't being more transparent about that. We have voice of customer data from our software product, Tether. We use it to raise awareness. Okay, that sounds like a good thing to know about. Tracking. COVID doesn't stop at the border. Yeah, very good point. Yeah, that's, I mean, I feel like that's a really important point to make about, you know, this is just one of like many news events that I think have really brought home the point that the world we live in is not as cleanly divided by the lines that are drawn on maps. And we should always be reminding ourselves of that. You know, the sort of ways that we view this information, and this information is mediated to us, really, you know, it hides some of the connections that and relationships that exist beyond those cleanly drawn lines on maps. So very good point. I'd like to visualize in a really interactive way. Okay, outcomes. Okay, local data. Okay, so somebody. Oh, looks. I'm going to bring this up right now that somebody just shared. Aiden. Let's look at this right now. All right, this looks really cool. It's like a county level. This looks really awesome. Yeah, it's yeah, it is a good point to continue making that. Developing those, if you can develop those relationships with your own county health officials and state health departments, and getting data directly from them, it's even better. All right, what we got? APM is tracking COVID cases and race specifically, and you can download data at. That is good to know. I did not know that. APM Research Lab. This is awesome. Cool. And it looks like they even have a little data viz section as well. I didn't look at this before. Oh, this is just for all of their data visualizations. Awesome. Yeah, well, so thank you all for sharing all that. This looks like some really awesome resources. So I encourage, I'll compile these, and in the follow-up email after the workshop, I'll be sure and provide these as well. Okay, so let's. Oh, somebody else said something. Some state and local health departments have not released information well at all. Other states have. Maryland had tracked and released things really well from the beginning down to the zip code level. That's awesome. Okay, so continue to throw stuff into the chat. I'm gonna take a break from looking at it right now and kind of move on to Vega. But if anything that comes up that you all want to share, just drop it in. That would be great. Okay, so now let's talk about Vega. So I mentioned Vega yesterday and described it as a kind of a visualization framework, and it is. Let's put that in the chat as well. And it is that. I mean, at a fundamental level, it's a package, software package like D3, which we can import into our observable notebooks. But the ideas behind it are kind of much bigger than that, and I think they're really cool. Vega describes itself as a sort of visualization grammar for describing the way that a chart is created and how the interactions work within it. And this kind of it borrows on these ideas called the grammar of graphics, which began as a sort of like more academic approach to describing visualizations. This how like less than like this sort of like particularities of like any software you might use, just a kind of description of a chart that is slightly more like universal. That is like how information is encoded into the chart, how data may be transformed by the chart, and you know, the idea of grammar graphics is pretty old. I think it may have even began in the 90s, but it sort of gains us a lot of traction with the R programming language package called ggplot. ggplot, the GG and ggplot actually stands for grammar graphics. I didn't know that until just recently. But it's sort of like the implementation of a sort of layered grammar of graphics that was created by this guy, Hadley Whitcomb, who is like the creator of a lot of really popular R packages like the tidyverse and ggplot. So, you know, if you're somebody who, if you know somebody who like does a lot of social science research, you may have heard them talking about R. A lot of journalists like R as well. It's kind of another language besides Python and JavaScript that's more narrowly tailored to doing statistical analysis, and people love it. ggplot is like, and the sort of tidyverse that it's part of is one of the reasons I think people like R a lot, because it makes it really easy to kind of think about data in a sort of higher level way when in terms of like the analysis that you want to do and the visualization that you want to draw. So, you know, Vega is like sort of another implementation of this idea of grammar graphics. Vega-Lite is a sort of related software package that's sort of even higher level than Vega. That is like, it's more concise and sort of makes it even easier for you to concisely describe like how you want to draw your chart. I don't think I've mentioned this yet, but you know, Vega-Lite is built on top of Vega, which is built on top of D3, the visualization library that we mentioned before. That's super popular, but also like really hard to learn. The thing that makes D3 so hard to learn is that you have to think at a really low level about how the data maps to like how pixels are drawn like on like in an SVG. And with Vega and Vega-Lite, you don't have to think at that low of a level. You can just sort of like provide it data and say, I want to map this field to this particular encoding channel, and see the output rather immediately. And the result looks a lot like a D3 chart. It's not as customizable as if you were working at that really low API level, but it produces some pretty cool stuff. Like you can look through their gallery and see things that people are making with Vega and Vega-Lite. And I think it worked. It's definitely passes muster for web and print publications. So I've had a lot of fun using it recently and also teaching it. And so that's one of the reasons I wanted to do this workshop, is to kind of like share it a little bit more. I'll also mention that Vega and Vega-Lite were created by folks at the University of Washington Interactive Data Lab. Let me see where they are. Where they mentioned. Yeah. And so you can check out this organization and see some of the stuff that they've done. They've got some pretty good videos describing the sort of ideas behind Vega. If you kind of want to dig into those a little bit, I would highly encourage it. Let's actually start talking about the sort of like interface to Vega and actually using it. What we're going to do is we're going to create a chart that is pretty similar to this one here. Basically, let me get a bigger version of it. So the New York Times has a chart that shows, I want to find the one that shows like the new cases. Yeah, so right here. So this is like the reported new cases by day in the United States. So the number, the sort of number of cases that are new in a given day. And so we're going to make a chart that looks pretty much exactly like this. Let's get started with that. So if you haven't already, go to Observable HQ.com, and we will create a new notebook. I'm going to say new. And I'm going to go ahead and just title this chart or this notebook. Let's call it new COVID, new US COVID cases by day. So there's my title, and I'm actually just going to go ahead and hide the title because I'm probably not going to mess with that too much. And so now I'm going to go ahead and so again, the first thing you want to do is import Vega-Lite as a resource that we can use. To do that, I'm going to say import, and I'm going to call it VL, or it is called VL, sorry, from at Vega-Lite API. And so just a reminder, what that's doing is that there's actually a notebook that contains the Vega-Lite API that is an observable notebook, and that's what we're importing. So we're basically importing from this this notebook a thing like the cell that's called VL. That's this one right here. So this is like everything we just added to our notebook, this cell right here. Now that we have that, let's go ahead and so the idea is the first thing we're going to do, maybe let's bring up the sorry, I'm trying to get this window here so we can kind of look at this as we're going. Anyone else getting an unexpected token? Okay, so let's take a look at that real quick. So be sure that you have VL from and then and have it in single or double quotes. So I'm actually just going to drop it right here in the chat for you, if everybody wants to grab that and use it. And you know, if it's helpful, what I'll do is I'll actually just kind of drop in my code snippets into the chat. So if people want to like just copy and paste, you can do that. But I would encourage you to kind of write it yourself, because that's a great way to get practice at using this. All right. So, okay, so let's start off by making a what's called a mark. And the mark is kind of like the basic it's sort of like one of the basic objects in Vega-Lite, and we'll render it. You know, a mark sort of represents, like marks are kind of like the shape we want to use to visualize. And so one of the options there is a bar, in case you want to make a bar chart. We can also use line or what did I use wrong? Connections. There we go. I guess I have to provide line some kind of argument. So that's why it's not working, but circle's another one. And probably the thing to do would be to actually show you all the full list here, because there are a few of them. Let's just bring that up real quick. Vega-Lite API. This would be a good thing to keep open as we're working, because we're gonna like be looking at this a lot. I'm gonna drop in the chat as well. This is sort of the API reference for Vega-Lite. Again, just to recall for what we mentioned yesterday, the API is basically like the interface that we're interacting with in JavaScript. And so these are like the descriptions of the things that we can invoke in the library. And so you see area and bar, you know, geoshape if you're making a map. These are all different kinds of marks we can use in Vega-Lite. So right now we don't have anything to show because we haven't provided any data to Vega-Lite yet. So let's actually do that right now. So I'm going to modify this existing cell and provide data to it. And in order to do that, I'm going to chain a method called data onto the mark bar. So mark bar, and then data, and then render. Render's the method we have to call at the end in order to render the chart. And so like in JavaScript, we can actually add carriage returns, like hit return to list our methods vertically, as opposed to just having them all just sort of one after the other horizontally, which can be kind of harder to read. Because we're gonna, you know, this cell is actually going to get pretty tall as we edit it. So because we're gonna be making lots of like method calls in order to render to get to rendering the chart. So for this to this data method, we can actually just provide a URL to the data that we want to use. And so as we mentioned before, the New York Times data is available online at GitHub. So I'm actually going to just go to the raw CSV file, copy this link, and I'll drop it in the chat too, so you can just copy it from here if you want. And then I'm going to put that in quote marks when I pass it into data to get the URL. And so now our chart has data, but it's really hard to tell because basically we just have a square, but really what this is like a bunch of squares like stacked on top of each other. Because what we haven't done yet is take the fields within our data and map them to what are called encoding channels. So an encoding channel is like, if you think about like, if you want your chart to have some sort of like, if you're trying to like take some part of your data and visualize it, you need to take a given observation, like you need to map that data to some sort of like visual signal that will show up for somebody who's looking at the chart. And so these sort of encoding channels or encodings can be things like the x-axis or the y-axis or color. These are all sorts of visual encodings that are part of this sort of like grammar graphics that are sort of implemented in the Vega API. So to add our first encoding, we're going to start with adding one for the y-axis, right? Because if we want to make a bar chart that looks like this, we need to represent the number of cases on the y-axis. And let's actually, it'd probably be good to look at this data that we're using as we're charting it. So I'm just going to bring that up as well. And I'll drop this in the chat too. Boom, boom, boom. So this is our data table that we're using. We've got 5 fields on it, a date field. Oh, actually, this is the wrong one. Sorry. It should be US, not US states. Forgive me. Right. So there are 3 fields. We have the date field, the number of cases, and the number of deaths. So like the number of cases cumulative, like reported as of this date, starting with January 21st. So let me make sure I get the right link in here. So if we want to show the number of cases on the y-axis, we have to add an encoding for that channel. Encoding, so it's the encode method, and we're going to pass into that method the encoding channel for the y-axis. So this is under VL, which is the name of the Vega-Lite API that we've imported. And you can see like various properties and methods that are available under that, speaking with Y. So this one's just going to be called Y for y-axis. And then we need to specify which field, and the name of the field is cases. So let's just go ahead and do that. And there we have, it's starting to look like something now. I'm going to drop this in the chat in case anybody wants to look at that. So we have now on the y-axis, we have encoded the cases to the y-axis. So we see like the total number of cases that have been reached, which is over 2 million, which is insane. As of the, basically we have like the biggest bar showing up seemingly just once. But the thing that's missing now is, we haven't mapped an x-axis. We haven't mapped any data field to the x-axis. And so let's actually do that now. I'm going to specify another encoding for VL.x. And the field we're going to use is date. Okay, so now we have cases mapped on the y-axis and date mapped on the x-axis, but nothing's showing up right now. And the reason, somebody says, why does it matter? Why does it matter is cases is capitalized. So the reason for that is that that's how it appears in the data. If you look at the CSV file, all the field names are lowercase. We can actually change the how the labels on the axes look by changing the title of the axis. So I'm going to just show you how to do that since we're talking about it. So it's sort of like a relabeling of so now they're uppercase. We don't see anything right now because the way Vega-Lite works is it makes a lot of guesses based on what you tell it. And one of the guesses it's making is like what data type these fields are, cases versus date. And if you look back at the data itself, like date is obviously in a format with a year dash month dash day versus the other two, which are just number fields, like whole integers. Vega actually has 4 different data types that closely align to like the sort of statistical data types that some of us are probably familiar with. Let me see if I can find the list. It's not here, but let me bring it up over here. Okay, so yeah, those 4 data types are nominal data. It's also sometimes called categorical data. So that's like if you have like sort of categories in your particular field. You've got ordinal data. So if the data has like a specific ordering, it's worth saying that like like a number or a string could be ordinal data, right? Like if there's a particular order to the string values, like that could be classified as like ordinal data. There's also quantitative data, which is just like an actual numerical value. And then finally we have temporal data. So it's like if it's a unit of time, that's one of the data types that Vega recognizes. And so in order to specify those, whenever we name the field, we can also name the type. For cases, right, since it's a number and we want to treat it like a number, we're going to call it quantitative. And then since date is a date field, we're going to use the type temporal. And look at this, like we've already got a bar chart. If you are somebody who's like tried to make something like this in D3, you know how many extra lines of code that this requires and like other like levels of thinking that we just got to skip over. So I think that's really, really awesome. Is one of the reasons I really like this library, is because I can sort of very concisely just say like, here's my data, my fields map to these encodings, and then here's the data types are, just show it to me, right? This is way more concise than like working at that sort of lower chart making level that D3 affords you. Okay, so I'm actually going to drop this mark name for my chart right now, and we'll see why here in a little bit. But so in case anybody's still trying to keep up with where I am, I'm just going to drop the code snippet that I'm at right now. So one thing to note is that like there's a sort of long period of time when not a lot's happening, and so it kind of makes the data look very skewed. What would be nice is if we could kind of like go back to like around early March when when the cases were really starting to grow, and show that, like, if we look at the times chart that we're trying to replicate, like it starts at March 1st. And so let's actually do that too. So what we have to do in order to do that is make a transformation on the data as we are providing it to Vega-Lite. So here's how we're going to do that. And I know I'm getting a little long-winded here, so I'm just going to do like a couple of more things, and then we're going to take a break and come back. All right. The thing we need to do now, as I said, is add a transformation to our chart. To do that, we need to add a transform method call right after our data. What we're going to provide to the transform method is a filter operation. So this is under the VL library that we have imported. So filter, and so the syntax for filtering is it's an expression that Vega prescribes. Let's actually look at the API reference to see how it works. There are a few ways you can do it. The most straightforward one is like where we use an expression that's provided as like a string, where you can provide some sort of filtering criteria. And the keyword is this word datum, which is like the current object that it's operating on. So like datum for like the singular data. And so that's the sort of like expression format that we're going to use to filter down to just cases that have happened since the beginning of March. Going back here, so again, the filter expression is a string, so there's no like the value of the date field that JavaScript recognizes is it's recognized as a string. It's not sort of typed as a date. And so what we need to do is use a sort of separate function to extract just the month of that of each date value. So what that looks like is just like the name of the function is just month, and then we say datum for like the current data object, and then date for which is the field. And then since it's a method call, we're going to close that. Then we need to set it greater than or equal to. This is going to be the sort of unintuitive part, probably at first. It's number 2, right? And that's because the month number that is extracted from this date string is 0 indexed. So January is actually 0, February is 1, and March is 2. And we want any observations greater than or equal to March. So we're going to use number 2 there. So let's go ahead and do that. Yeah, and so now we kind of have chopped off everything except the beginning of March. So already we've made some pretty good progress here. Um, one thing that's worth noting is that there's what we're looking at now again are like sort of the cumulative number of cases, so we can see it just sort of like growing steadily over time. If we look at what the New York Times chart is, again, it's actually the number of new cases each day. So we're going to have to do some more sophisticated transformation in order to get that number. And so we're going to do that here in a minute. But before we take a break real quick, I'm going to, just to make it very clear like what this information is, I'm going to add a title to my chart. And so that's another sort of easy method chain, a method that we chain on at the bottom here. And I'm just going to call it title. I mean, the method is called title, but I'm going to call the chart cumulative US COVID cases. So now that shows up there. All right, so I've been going for just about an hour exactly. And so I'm going to, why don't we take like a quick 5-minute break so everyone can get some water, coffee, whatever. And then we'll get started. We'll actually make it just a little bit longer than that so people have time. But we'll try and get going again, let's say at, let's go ahead and say at 10:10, well, 10:15, how about? Does 10:15 sound good? I'm just gonna, yeah, we'll give us a good, a little more than 5 minutes. All right, so I'm gonna be right back, and I will we'll resume making this really awesome chart. Okay. Okay, everyone, just about to get started again. A few more seconds before we get going. Before I took a break, I dropped in my current code snippet for this chart into the chat. So if you need to kind of catch up to where we are, you can copy and paste that. All right, let's get going. So the thing we want to, our sort of next task is to convert this cumulative data to show us the number of new cases for each day. And so as I mentioned before, that we have to do another sort of transform to our transformation to our data in order to sort of calculate that number for each day. And so I'm actually going to keep this chart up here as is, and I'm going to make another one in a different cell where I'm going to do that extra transformation. And I'm going to call this one the daily new US COVID cases. So right now at this point, it sort of looks the same as the other one, but it's just a different title. I'm going to bring up the Vega-Lite API again real quick so that we can kind of look at the transformations that are available to us. Data transformation, right? So there's a whole, thank you for mentioning that. Yeah, so just to remind everyone what I just did, basically took this cell, I pasted it into this cell, and I changed the title. That's the only thing I did. So these are all different transformations we can do on data using the Vega-Lite API. We've already shown the filter one. The one we need to do right now is what's called a window function. And you may have run across this in like other computer languages or software like Excel or SQL, SQL, where you want to do some sort of operation over a partition of your data. That is like in our case, if we think conceptually about what we're trying to do, right? For each day, we want to take the difference of the current number of cases for that day minus the number of cases for the previous day. And so that's kind of our window for this operation, which is sort of two value window. And Vega-Lite has the concept that the name that Vega-Lite has for that concept is called a frame. Let me just pull up the window API reference real quick. So let's actually start by defining our start by defining our transformation we're going to do and setting that frame. And so this will be another transform that transformation is happening within this one method call to transform. So while I passed in filter, I'm also going to pass in another one that will be VL.window. And so for starters, I'm going to set that frame that we talked about. And the frame is going to be defined like this: -1 and then 0. So 0 for the current, datum, and -1 for the previous one. That's the frame that we're operating in. I'm seeing some. Yeah. Okay. Thanks. Thank you all for weighing in and helping other folks out. I really appreciate that. There's my frame, but now I need to define the operation that's going to happen. We sort of have to break this down. It's not quite as easy as just taking the difference. We have to actually kind of create a value for each observation that points back to the previous cases. So, like looking back at the data itself, right? Like we have the number of cases. What we need on this table are 2 extra columns. We need 1 column for the number of cases from the previous day, and we need another column that shows the difference between the cases and the previous cases. So it's actually kind of like 2 transformations, not just 1. The first one sort of defines that previous cases value, and then the second one does that calculation for us. So the one we're doing right now is the one that defines the previous cases. And so the specific window operation we use to do that is called first value, meaning that it's like the first value within the frame, which in this case will be the previous value, the -1, the one that's in the -1 position in the frame. And so the value is the field that we want. We sort of reference that by using the field name. So this actually gets us the previous cases, but we also need to rename it so it's not like clashing with our cases field name. So I'm going to rename this this sort of transformation as, I'm going to alias it as previous cases. Okay. And where did I go wrong? It should point to it. Oh, I think that, yeah, so one thing I'm missing here is, I believe it's right here. Yeah. Okay, there we go. So maybe it'd be worth, I like to like add lots of, partly because I do a lot of Python stuff too, so I'm used to like extra white space, but I like to like kind of space things out in this way, so that I can like not have those sort of syntax errors with like missing brackets and parentheses, right? So we've got 2 transformations defined now. The first one is the filter. The second one is the window function, which will which is performing this operation to get a previous cases value. Now let's add the next one, the next transformation, which is the one that performs that calculation that we talked about. That's another transformation that's available through the Vega-Lite API, and it's just called calculate. And sort of similar to how we did the filter method, there's this sort of like expression syntax we can use to define the calculation we want to use. So yeah, so using this sort of expression string that can they're all defined in here somewhere, but the one that we want to do is basically just doing the just taking the difference, like it's this simple like arithmetic, it's just a subtraction. So here's how we're going to do it. So for each row, for each datum, we're going to subtract the cases, the current number of cases, from datum dot previous cases. And then we're going to name that as new cases. So I just added that, I just ran it, and you notice nothing's changed yet. And that's because while we've made this transformation to create this previous cases and new cases fields, we haven't encoded those yet. That's why it still looks the same as it did before, just by showing us the number of cases going up steadily every single day. So we need to change our y-axis encoding to be new cases. New cases. Now, there we go. We have that daily number of new cases for the United States. Does that make sense? Everything we just did? I'm going to drop it in the chat so people could copy and paste or sort of compare to what they have. Really, we only made a couple. There's really just like 3 minor changes we made between this chart definition and this chart definition. We added 2 new transformations: the window operation and the calculate the calculate transformation. And then we changed the y-axis encoding, and we changed the title. That's all we changed to get these different results. And if we look at this chart, it's actually starting to look more like the chart that we're trying to mimic in the New York Times. You know, at this point, we could also make some more changes. Like if we want to sort of customize the size of the chart, we can do that using the height and the width methods on our mark. So I'm going to set any, what we pass in here are the pixels, the number of pixels we want to use. So I'm just going to take a wild guess here and say, I'm going to start keeping it square. And then I probably want to make it a little bit wider, and we'll say 600. Yeah, it's starting to look a little better. We can actually just pass in here something called width, which is the width of the cell, to make it kind of responsive. The width is like a dynamic value that's provided by Observable. You know, one thing we're kind of doing here as we're modifying the height and the width of the chart is we're sort of changing the shape of the chart, which can kind of very subtly modify people's perception of it. So like as we make it longer, right, the line gets flatter. If the chart were narrower, we would see it distorted to show a more drastic line up, right? And just, you know, if you've worked in photojournalism or photo editing, you know about like aspect ratio, right? Like how distortion can happen. And so that's something that is those sort of like concepts translate over into making data visualizations as well, right? Something to keep in mind as you're it's often sometimes the aspect ratio is just defined by the space that we have to fit the chart in our, especially if it's going into a print publication or into on a web page that has a bunch of other stuff on it. But it's definitely something to keep in mind. So somebody says they're getting an error. I'm just going to put all this in here. Okay. I realize some people are having some sort of syntax issues. I'm not going to be able to like troubleshoot all of those on the fly. Again, the notebook's going to be available in its full form after the workshop, and so you can kind of maybe go back and look at it. I didn't want to keep moving because I have a couple more things I want to demonstrate. So something else that this chart has that we would like to add is like this 7-day average. So this line that shows the the average number of new cases within the last 7 days, the average of the in that 7-day period. We can do that line chart as well. That number, that 7-day average number is not provided for us in the data, so we have to once again do a data transformation to calculate that. But that's something we can do. So let's try it. So I'm going to take this entire data cell and copy and paste it down into another one, because this is going to be a whole new chart that I'm going to call, that's going to be a line chart. So, all I had to do was change the mark from mark bar to mark line to get an entirely different chart, like a line chart versus a bar chart. Right now, the shape of this line is exactly the same as the shape of the bar chart. But so let's do this transformation to sort of calculate that 7-day average. This is going to be another, require another window operation. But in this case, the window is slightly bigger, right? Like before, when we were adding that previous cases field, we did that by defining a frame that was started with the previous day, -1, and ended with today, the number 0. So as you can imagine, if we want to create an average, that is take the mean of the 7-day period leading up to today, then we need to go back a little further, right? In the so instead of -1, it's going to be -7. So let's just do that real quick. So we've got 1, 2, 3 transformations. I'm going to add another one. One thing I'll point out, a little bit, people are noticing I'm doing this, like between each one of these transformations, there is a comma. You're getting some token errors. It could be that because these are like all arguments we're passing into this transform method call. Each one of those arguments has to be separated by a comma. And so the end of each one has a comma. Actually, somebody point out it should be -6. So that is a very good catch. I appreciate that. So thank you for that. So let's do that real quick. The VL dot, so again, it's going to be a window, a sort of window transformation we're doing. Previously when we did a window transformation, we use an operation called first value. The operation we're going to use this time is the one that calculates the mean for us. And so that is performed by just using the mean operation. And then we provide to that the field that is going to, we want to take the mean of. So that is going to be, in this case, the number of new cases, the sort of calculated field that we have. So new cases. And then we want to add a name to a sort of alias to this calculated field. And we're going to call it the rolling mean. So it's sort of the average, the sort of mean over the 7-day period for the entire span of the chart. And the other thing we need to be sure to add is the frame. So frame is looking out -6, 0. Let's go ahead and do that. And again, notice nothing changed at all, because once again, just though we calculate the field, but we did not add it to our encoding. We want this field to show up on the y-axis. So I'm going to change new cases to rolling mean. Look at there. Now we have that number of new cases, and we'll rename this chart to we'll call it average, or 7-day average. Or maybe the daily 7-day average of new cases. Now the title's changed. So two informative charts. The New York Times has these sort of layered on top of each other. So that's something we can do in Vega as well. We can sort of concatenate charts and sort of layer charts as needed. So let's do that. It's actually really, really easy to do. The first thing we need to do is, I mean, we could do all of this in one cell, but I kind of like how we have each chart sort of separated out and drawn separately. What I want to do is just create another cell that does this layering, so that I can like see each chart separately, but also together. So in order to do that, we have to define a name for each chart so that we can reference it. So I'm going to go back up to my daily new US COVID cases, and I'm going to drop the render method call at the end. And I'm going to define a name as bar capital chart, bar capital chart. And then I'm going to do the same thing here. I'm going to drop the render method. And I'm going to call this one line capital chart. If I still want to like look at these, I can. What I have to do is just say, you know, bar chart, and then render line chart, render. Did I spell it wrong? Might not work. Oh, there we go. Yeah, it's not a function. I always believe the error message. It's what I always tell myself and other people I teach coding. Yeah, now let's layer the charts real quick. One other thing we need to, so it's not going to be very
clear if we just use the same color for both the line chart and the bar chart when we put them on, when we stack them on top of each other. So we can customize the color of the line by passing in an object to set the color when we define the line the line mark. So I'm going to use color red to do that. And yeah, now the line's red. So now let's put them on top of each other. To do that, there's just a simple layering that we need to do. So VL.layer, and then we pass into the layer method the bar chart and the line chart. And then we have to render it, of course, in order to see it. Boom. And then we've got two charts stacked on top of each other. So, you know, looking pretty good compared to what we're sort of going against. So now it's probably worth maybe taking a moment to if anybody has any questions. I've got like we've got one more exercise I definitely want to get through, and some other like sort of tricks I want to demonstrate to people. I don't know if we're going to get to the mapping that we talked about, but okay. So somebody said drop the color. Yeah. So all we did was we defined like color, like an object or an associative array of like color red, and we pass that into the mark line. Here's the full line chart definition, and here's the thing we do at the bottom, the VL layer. So did I miss the other questions? Can you drop? Okay. How did you change color? Okay, yeah. How do you determine when you use tick marks versus quotes versus single quotes, or which type of brackets or parentheses? How to integrate these charts into other mediums as interactive elements, so you can hover over the bar and see the values. We can do some tool tips, and I don't know if we'll have, I'm not sure if I'm prepared to. You can do like the kind of like hover over effect that we saw on the New York Times chart via what's called a selection. I'll try to get that. I'm not sure if I will. If I don't, I'll add it to this chart and then publish it out, publish the notebook out. But we can do that in those interactive elements, and we'll at least show the tooltip part, so you can see that. So to answer the question about parentheses versus, you know, ticks or quotes or whatever, some of this is and it's determined by the syntax rules, right? When we're calling a function or a method or invoking it, we always use parentheses. That's what like if we don't use, like if I weren't using parentheses here, what I get back is just, because all I've done is sort of reference the function itself. I haven't invoked the function, and so that's why the output of this line of code is just like, yeah, it's a function, and it looks like this. Anytime you are calling a function or a method, you're going to have those parentheses behind the name of the method. The quote marks, single or double, or the ticks are how you set off a string value. And if you recall yesterday when we talked about, and we'll see this in a little, this will come back to us in a minute when I'm going to like use another template literal to evaluate some code and then sort of add that to the string value. The tick marks are for when we are using a template literal, such as when we are doing Markdown or a string literal or HTML. That's when we definitely need to use the tick marks. If it's just a string where we're not like using any templating, like we're not like evaluating values and putting that into our string, we can just use single or double quotes. And the only thing there is we have to be consistent on both sides of the string. Both sides need to be single or both sides need to be double. So square brackets denote an array. So like if we have like a list of items, that's what square brackets are for. If it's an object, that's what the curly brackets are for. And so, and again, the difference between arrays and the objects or associative arrays is how they're sort of indexed. Square brackets, arrays are numerically indexed. So 0, 1, 2, 3. Objects or associative arrays are indexed according to keys. So like in the case of the color, we passed in an object with the first key named color and the first value of the string red. It's really like it's a lot to remember the first time you're exposed to all of it, and like we kind of raced through it yesterday, and then like I'm racing through it again to explain it all. You really just kind of like get used to it over time. And again, like the sort of error messages that come up as you're writing your code, we'll try to point you to these problems. Like when you get those sort of like, let's find one right now. So notice how, I don't think I pointed this out when we were talking about errors yesterday, but notice how this red caret mark is pointing exactly to where the parsing of the JavaScript failed. It's saying the error message reads syntax error, unexpected token. So it's basically saying that like, hey, like I got a token or a symbol that I didn't really expect to get, like at this point when I was parsing the JavaScript. And it's actually pointing to the unexpected token, which is the letter V. And so it's kind of trying to tell you like, hey, like there should be something else, like this isn't supposed to be here. Maybe there's something different that's supposed to be here, or maybe there's something that's supposed to come before it, which in this case is a comma, right? Because again, we're calling this transform method, and anytime you call a method or a function, if it has arguments in it, those arguments have to be separated by commas to sort of delimit the things you're passing in to that method or function. Really the best teacher you're ever going to get when you're writing code is the environment you're writing in. And that, when I was first learning how to code, like that was something that was really like valuable for me, is the feedback of the thing I'm writing in. Like, I like to also just write prose as well. But one of the things different from when I'm writing, like, just sentences and paragraphs is like, I don't get that feedback that's telling me like what is and isn't like working. I have to sort of go back and read that myself or have an editor do it. But, the environment that you're writing your code in is like, it's a very strict editor. It will tell you when there's a syntax error or some others like a mistake. And it's just trying to point you to where to what you need to fix. It's the best teacher you're going to ever have. And that comes, with time too, right? Like just with practice. Okay, so let's see, we got some time. All right, so one thing I definitely, can we use Observable to show COVID data on a map? We can. I don't know if we're gonna get to do it today, but I'm definitely going to like put out a notebook afterward that demonstrates this. I am going to, what I want to show next is a kind of cool trick for sort of creating a notebook that allows anyone who doesn't even have to write code to go in and sort of generate sort of a charts based on a template. Let's do that. And what I want to do basically is we have this sort of national level new cases and 7-day average. But wouldn't it be awesome if like we had a thing that would allow people to go in and sort of generate this chart for their own state? That's what we're going to do right now. And so people are asking about embedding, and we'll demonstrate that as well. I'm going to shift gears and create a new notebook now. So we are going to leave this one behind, but before we go, you might want to keep this tab open because we're going to do a little bit of copy and paste because we're going to reuse a lot of the same stuff we have here in our new notebook. So let's just keep this open, and I'm going to go back up here, and I'm going to say new notebook. Okay, and I'm going to call this notebook the state level COVID cases chart builder. I'm going to unpin that. All right. We need to, once again, import Vega-Lite. VL at Vega, Vega-Lite API. Where is from, right? Again, unexpected token because I forgot what goes there. And then another import we're going to make is, if you remember yesterday, we imported an input for creating a slider so that we could sort of change the, or actually no, it was a select we imported. So we could change the selection of the dog breed for the dog pick fetcher. We're going to do the same import right here because what we want to have is like a drop down that's going to allow users to select a state that's going to then generate the chart for that state. So import select from and again we're getting this from this guy Jeremy Ashkenaz, who has a notebook that contains like all these input utilities. This is called inputs that we're going to use. So that we're going to import select from Jeremy Ashkenaz's inputs notebook. So now we've got that. Okay, so let's get going on this. One other thing that's going to be different this time around is, so in order to have a select of states, we have to get a list of states and populate our select with those options. The way we're going to do that is we're going to get the distinct state values from our data set and use that as our select. There's possibly another data source out there that just has the list of states, but I kind of like to have like just the values that are actually just the states that are available in our data set. so that there's nothing, there's not any sort of difference in the states that are available in the selection of the select input versus the in the data set. So whereas before we got our CSV file from the New York Times and put it like sort of straight into the Vega-Lite chart via this data method, I'm going to instead grab this URL, and we're going to use a utility in D3 to download the CSV file. So another thing we're going to add to our notebook, and this time, since it's D3 is a package that's on the Node Package Manager npm, we're going to use require to pull that into our notebook. So require, and we're going to require D3. Okay, now to get our data, I'm going to call it data. We can just use d3.csv. And then we can throw in that URL. And you need to, it needs to be a string, so put single or double quotes around the URL name. And so now we have our data. We can actually like kind of drill into the data if we want to see the number of cases for each, so this is actually the number of cases for each day, right? So I'm sorry, isn't there a small change we need to make? Like, we need to switch which source file we're using to, instead of the number of cases for the entire country, but we're going to do it now for each state. So that's like a different CSV file, also available from the New York Times, called US States. Yeah, so now we see the state name and the FIPS code for each state within each object within our data. Cool. And so while I'm looking at that, let's just go ahead and change this up here to states as well, so that we can like kind of look at the data as we go. Wait, what just happened? Oops. So states. I don't know why this is opening a separate window. Just gonna try that here. There we go. States. Okay, there we go. Yeah, so that's the data file we're working with. All right, so now we've got our data. So now we need to get that distinct list of states. And in order to do that, we're going to use a method for calling a function on each object within our array of data that's available to us through D3. It's called map. I'm going to declare a new variable called states, and I'm going to set it equal to d3.map. So the map function, or the map method, allows us to provide an array, which is this data array we have here. And then also we can provide as the second argument a function that we want to perform on each item in the array. And since I haven't defined that function already, I'm just going to use the sort of shorthand arrow function definition to describe that function I want to perform on each object in the array. And so in this case, that'll be d arrow and then d.state. So d is sort of like the name of the argument to the function, and then the return is d.state. So let's actually see what that looks like when we do it. So you notice now that like now we have a new object that has each state listed. And in order to get just the state names as an array, because that's what we need in order to provide it to our select, we need to get the keys of this object, which we can use the keys method for doing that. So keys, right? And now we've got an array again with each state, but they're not in order, so we need to sort them. So this is one more method call for sort to do that. Now we've got Alabama, Alaska, Arizona, Arkansas. So I'm just going to drop that in. I think I haven't been doing all my imports either, so I'm going to do this one at a time. So here's the one for importing Vega, importing select, requiring D3, getting our data, and getting our array of states. There we go. Okay, so let's go ahead and make our state selection thing. So here's how we're going to do that. I'm actually going to I'm going to insert a cell at the top of my notebook, because I kind of want the state dropdown and the chart that's going to be driven off of the dropdown to appear at the top of the notebook, so somebody can just come to this thing and like select the state they want and get the notebook or get the chart. To do that, we're going to do a view of a variable called select state, and select state will be set equal to select. That's the utility that we imported for using a select, and then provide the states array to that. Right. So now I've got a drop down with all those states in that array. Okay. So now let us define our bar chart and our line chart, and then our sort of layer chart, again, just like we did in the previous notebook, with a few modifications. So I'm going to go back to my previous notebook. Well, let me just add this to the chat as well. And so here's my bar chart. I'm going to select everything in this cell. And I'm going to add it right here. So let's just point out like the things we need to change in order to make this a state level chart versus the national chart, which we have right now. So first of all, we're going to change the data, right? Now we're going to be getting it from our data source that we've already defined up here, coming from the CSV parse from D3. So let's just do that. So I just basically changed data to data. And the other thing we need to change is we need to add another filter, right? We've already added one filter to exclude observations before before March 1st. now we want to exclude, now we want to filter down to just observations for a specific state in our data set. So that's just another filter that we're going to add into our transform method call. And this one's, the syntax for this one is going to be just a little bit different because this is the way I can figure out how to make it work. These, and we'll kind of see this in a little bit, but there's actually kind of multiple ways. The way I'm demonstrating to write the Vega-Lite, the code for interaction with the Vega-Lite API, I'm trying to do it like the most concise way possible, but there are other ways to specify all this that are much more verbose and explicit. And the way this way I'm about to demonstrate is kind of like one of the more verbose ways. But let's just see it real quick. So it's another filter method, and we're going to pass into this filter method an object with a key of field for the name of the field that we want to filter on, which would be state in this case. And then we are going to also pass in a key naming the operation we want to do. In this case, the operation is equal, or not. It's not the operation so much. It's like the comparison we want to do, and then we want to test for equality between the value in the field state and the value select state. That's the name of the variable that we declared up here for the dropdown. Let's go ahead and do that. Expected token. Where did I forget? Oh yeah. See, we can see right here again. I forgot that comma right there. Another thing we want to change about, well, we can actually just drop the title altogether here because since we're going to layer the charts, we're not going to have the chart on this sort of each layer, but on the two layer together. I think that's everything we had changed here. So let me look through it real quick. We added the filter, and yeah, I believe that's everything. Okay, so now we're just going to do the same thing for the line chart. So let me go back to the line chart from my previous notebook. I'm going to paste that in to a separate cell. And again, change the data source to data, and then add the same transform method that we had up here. So that when the other filter, I'm just going to copy and paste it, and so I'm going to add this in to the chat as well. Okay. All right. So, and then I'm going to drop this as well. Title is. So now I'm going to unpin this. We don't want to show it anymore. I'm going to add another cell that's going to be VL layer, and we'll layer the bar chart and the line chart. And then I'm going to set the title. And the title is going to be, this is where we're going to go back to using a string literal, so we use backticks, right? Because we want the title to include the name of the state that we have selected, not be like just US, or have be the same name. So we're going to call it new cases in and then $, and then curly bracket, and within the curly brackets, we're going to do state, state select. Is that what I called it? No, select state is what I call it. Select state. And then we also have to render the chart. Cool. And now there's all of the, we have the little chart generator here. I'm going to unpin that for now. So, yeah, this is something that you could like give to a colleague in order to explore at the state level if they needed to. The one other thing I want to demonstrate in this notebook is how we can take this chart and like take it to other places. The thing we need to do that is import a utility called Vega Embed, which allows us to get an SVG or PNG or the actual JavaScript, the full JavaScript that defines the Vega specification for this chart, so that you can take it other places. So people are asking about key. Yeah, you can add legends and sort of annotations to your charts as well. I'll try to show that. I'm sorry, we're kind of running out of time here, but I do want to show just at least 2 more tricks here before we break. So I'm going to do that real quick. So how do we get this chart into other places? What we need to, in order to do that is this thing called the Vega Embed tool, which is available to us from NPM. So we have to, require that like we did D3. So I'm going to do that as well. So I'm going to call it embed. So, and now that I have that, I need to call that embed function and feed it all of my chart information. And so how I'm going to do that is I'm going to go back to my cell for where I define my sort of layered charts. And instead of just rendering the chart like I have right now, I'm going to add a view of, because this is kind of like similar, this embed thing is kind of similar to the select and other input utilities in that like it creates an HTML element, a div in this case, that has this extra stuff around it for sort of getting the SVG or a PNG of the chart. So I say view of, and I'm going to call it post variable just view equals. I'm call the embed utility, and I'm going to provide it all of this stuff for my chart. I don't need to render it like I did before. Instead of calling the render method, I'm going to call a different method, which is toSpec, which means to specification. Actually, let me just show you what that looks like before I do the embed thing. Sorry. So when instead of calling toRender, I call it toSpec, which gives me all this JSON that defines the chart according to the Vega-Lite schema or specification. Like when we're writing the code in JavaScript in Observable, the output of that code that we're writing is actually this JSON that can be ported to other places, and it's sort of like this is like the full set of like the definition for any sort of Vega chart, or in this case a Vega-Lite chart. So like all the stuff about like the data, the transformations that are done, and you can see like the definitions we have down here are all sort of compiled down to this this JSON, so like we can actually like we could write out we could create the chart by like writing all this JSON by hand, but the Vega-Lite API we use in Observable kind of makes it a lot simpler. But in order to do what the embed function is expecting is that JSON that meets this specification for a Vega chart, and so that's what we have to provide to it. When I say view of view embed, I'm going to provide that to it. And this is actually a little bit too big, so I'm going to make it a little bit smaller. Let's do 350 and 350. Or I guess I could just take all these off here and do it in one place, couldn't I? Oh, it's not the height that I'm worried about. It's this little one here. Take that off. Take that off. And in the so in the embed here, so I'm going to just make another change to this, and set the height and the width in this cell instead. So height. We'll set it to 400 again, and the width, let's just say it's going to be 600 right now. Okay, so just want to make it slightly narrower because this looks exactly like what we had before, but the difference is that you notice this little circle up here with these 3 dots in it, and that's what we got. That's what was added by rendering the chart through this embed function call, because now we have the options to save the output as an SVG file. So in case you wanted to put this into Illustrator to make some further tweaks to it, you could do that. You can also output it as a PNG file. So the other thing is the option is this Vega Editor. And so this is like an online tool that lets you create Vega charts, like just writing the pure JSON like we had that this compiles to. So that like 2-spec, like all that JSON we saw out here, like that's what we're seeing right here. And this can be this editor can be kind of useful for messing around with your charts and tweaking them. At least I found that, especially when I'm like like a debugging mode. That's one way we can get the charts out of this notebook. We're a little bit out of time. What did you change if not the height? I changed, so on the line chart and the bar chart, I took off the height and the width because I'm setting those now in the, after when I layer the 2 charts together, I'm setting them up here. This chart definition is going within that sort of embed method call. Right. Running low on time, but let's. All right. So one thing I definitely want to demonstrate, because somebody emailed me about this yesterday, is how you can like we're seeing how we can like use CSV or JSON files that are available to us like at a URL on the web. Let's actually show you how you can import your own CSV file and use that in case you've got a data file that you want to use in Observable. Yeah, I'm going to drop this in real quick. I want to make a new notebook real quick. I'm just going to call this upload demo. Under these three dots up here, we have some notebook actions, including something called file attachments. And so the idea is that for any given notebook, you can have one or multiple files that can then be sort of referenced in your notebook. So what I'm going to do is click this file attachments, and I'm going to upload a file that was sent to me by Aiden, which has some data that he has for Yakima County. And I'm going to click open. And so now that file is uploaded and it's available as an attachment to this notebook. And so in order to interact with that data in that file, we've got to add a few cells here to do that. We need to have a cell that references the file attachment. The way we do that is we use the attachment attachments is what I'm going to call the cell, but it's the file attachment function for getting the file, and you can see it it's going to pre-populate it with the name of the one file that we have attached, Yakima COVID.csv. Now we have this attachment name, we can also see the data within that. So I'm going to use attachment .csv, attachment.text to see the text of the file. And there it is. This is just plain text. So we see the carriage returns and we see the comma delimiters. It's not parsed as a CSV file yet. So we've got to add a couple more things to make that happen. One of them is we're going to use another resource from D3. So I'm going to say D3 equals require D3. And then in order to get the sort of parsed version of the data, I'm going to use, I'm going to call it data equals D3.csv parse. I'm sorry, CSV parse. Yeah. CSV parse, and then I want to pass into that text. I'm sorry, not text. I'm going to pass in attachment text, like the text from the attachment. And text is a function, so it has, or it's a method, so it has those parentheses on the end of it. And then I'm going to pass in also D3 autotype, which is going to help sort of guess the data types for the values. So I'm going to do that. What did I forget? CSV type error. Char code is not a function. I'm not sure. We'll try this again with maybe without the T3. some reason it's not parsing the CSV file. I'm gonna actually try it just like this. Oh no, it is CSV parse. That is the correct method. Is it parse rows maybe? Maybe something up with this. We'll kind of look at this again. 1, 2, 3, 4, 5. 1, 2, 3. Sorry, I should have actually tried this before I tried to demonstrate in front of everyone. It's what you get for like running with scissors in front of the crowd. But this should be the way to. And we've attached the file successfully, and we're just trying to parse the CSV file. And I guess there's something that actually, let me try this. I don't know if this is going to matter, but maybe something I just have to work out after the fact. I know I've made a lot of promises about follow-ups here, but I do intend to follow through on all of them. Just to sort of, okay, there's text, and then I'm going to try it like this. So data equals G3 CSV parse, and then I'm going to pass it in text. What is that? Okay. Text. And then, okay, that worked. Okay, I guess I need to like actually call the function to get the text out before I pass it into CSV parse. So sorry about the snafu there. And then we're going to pass in G3 dot autotype as well to autotype the all of the data. Okay, so now we have an array of objects, one for each data, and then we could operate on this data just the same as we could. Nice. That's a good call, Cody. I think you may be right on that. I wasn't thinking about it. It's probably providing a promise, not yeah. So anyway, this is working as well. More than ways to skin the cat. All right, just about out of time. So I kind of just want to make a list of things that we didn't quite get to that I want to kind of push out to people after the fact. So I know we wanted to see some like hover over and like tool type, some tool tips in our charts, and that's actually a pretty easy thing to do, and I'll add that to the notebooks that we've already done, and sort of explain how that's done in the notebooks. And then we also wanted to like show like the creation of a map and a map chart, and so I'll do that as well. Is there anything else that that people were really hoping to get out of this that maybe we didn't quite get to cover? You know, more than anything, what I hope that I have demonstrated to you all is the power of Observable, especially coupled with Vega for doing data visualization. Again, like the big takeaways for me are Observable is this awesome cutting edge tool for doing computational notebooks, which I think are like one of the best implementations of like a sort of data exploration and data diary type of environment. Vega is the chart building framework that I find to be a much more straightforward way of defining how you want to visualize the data you're working with. We've kind of just scratched the surface of both of these things. Like one really awesome resource I'll just point out before we go, in a lot of the stuff that that I've been using as I've been learning this is the observable notebooks that are put out by the folks who made Vega, and they have a really awesome series or collection of notebooks that they use in a data visualization class that they teach at the University of Washington State. That's it right here. I'm just going to drop this too. So some really good stuff in here for learning, mostly for learning Vega, but also some tips for Observable as well. And one other thing I'll mention before we go is, if you kind of like Vega and like the idea of Observable at least, but aren't that interested in doing so much JavaScript coding, there's the corollary for this in Python is Jupyter, which we mentioned yesterday. And I would definitely recommend like using Jupyter Lab, and another tool called Altair, which is basically just a Python API for Vega. And so you just pip install Altair, and the way we sort of defined our charts in this workshop is pretty similar to how you would define them if you're working in Python. So people are asking about pulling in data from a Google Sheet. There probably is a way to do that. I haven't never tried that myself, but the way that we fetch data from a URL, like in a GitHub repo, there's probably a way to fetch it from a Google Sheet too. But I've never tried that before, but I wouldn't doubt it. That's a good note that I'll look around for something like that and share that out if I can find it. Let's see. Anything else? Can you? Yeah, you're welcome. All right, we're kind of at time right now, and I don't want to take up the rest of everyone's morning. I really, really appreciate you all sticking through this, and I hope that you find this stuff useful. If you're doing some, if you want to continue working with this and you have any questions, like feel free to reach out to me, because I love talking to people about this stuff and trying to think through the problems as well. How would you actually embed one of these graphs or maps into an outside web page? Yeah, so before we go, I will, let me just show you that real quick. One thing you can do, if you, once your notebook is public, so let me just do that real quick. Where's my, I'm going to publish this notebook real quick, and then I'm going to modify the this final cell here and say I'm going to call this chart. Once your notebook is public, or published, and you have a name for a cell, if you click on these three dots here, you get the option to grab an embed code for that cell. If you take this, And then, this is functioning kind of the same way that we saw import working when we were like referencing other people's notebooks in our own notebook. Like we have to have the cell has to have a name in order to be sort of identified. But we can take this and drop it into some HTML to have it render the chart on a web page. One sort of caveat to this is that like this ID for the cell will change as you make changes to the chart. So if you're trying to like have a chart that you can like sort of modify the data for frequently, it's not going to like automatically render for you on your web page if you use this embed code method. There's probably some other ways of dealing with that problem, but this is one way you can sort of embed the code, embed the chart in another place, especially if it's like a static chart. That's one way of doing it. Okay, so thanks again to everyone, and yeah, stay in touch. I love working with folks on this kind of stuff. If you have questions, just reach out to me. There's lots of other journalists out there using Observable as well. Like if you post up to like the News Nerdery Slack, if you're familiar with that, you're probably going to find some lots of Observable fans that I will be more than happy to help you out. All right, so have a good weekend and good luck out there. You all are doing really awesome work. Journalism matters, and I appreciate the time we spent together. Thanks a lot, and just this. All right. Okay. Bye, everyone. Bye.